Okay, may as well get started. Welcome, everyone. Thank you for choosing to spend this slot in this session. You could have been anywhere else in this building learning a lot of useful things, but instead you're here to talk about cats. That's a good use of your time. My name is William, and I want to start with a disclaimer. So I am not a cat person. Now, for those of you that are dog people in the room, don't get too excited because I'm not a dog person either. I think if I'm limiting myself to be a one type of animal person, that's a bit too restrictive. I like dogs, I like cats, I like mice, I like birds, I like goats, pigs, cows, anything. As long as the animal is affectionate, wants to play with me, enjoys head scratches and cuddles, it's a great animal to be around. In fact, when I was growing up, my grandparents had a farm. And on that farm, there was a cow, E-I-E-I-O. I'm sorry, you deserve better than that. You're not going to get better than that in this session, though, so too bad. They had a cow, and this cow was my favorite cow in the entire world. It was this light brown color. If you sort of squinted in the sunlight, it would have like a little bit of red tinge to it. It was a very cute cow. I called it Rex. She was probably about this tall, although I was a lot shorter then, so in hindsight, probably about this tall. And in the mornings, I used to wake up and leave the sort of farmhouse area and go to where the animals were kept, the livestock. And as I walked through the gate into where the animals were kept, Rex, this cow, would come running towards me, very, very happy to see me, and we would play and walk, and she'd follow me around all day. In fact, I used to play fetch with her. So I would take a stick or a seed pod or something like that, and I'd show it to her, and I'd throw it. And I swear every word of this is true. So I would throw the stick, and she would completely ignore it. But when I went to go fetch the stick, she would walk along right next to me, bumping against me, having a good old time. So any sort of animal that likes affection and likes to play with people, that's what I'm sort of into. Now, in this session, we're going to be talking about securing modular monoliths, and I cannot say that word. Security is a big topic. There's consultants that make a lot of money going into a lot of detail about some of these things. I'm not one of those people, and I want to make sure that I'm giving you what you want out of this talk. So before we spend an hour and I don't cover what you want me to cover, I'm going to list exactly what I'm going to talk about for you so that you can decide whether or not you want to go and learn about Git or something else. So you're not forced to sit in the session and get right to the end and then say, well, William didn't cover what I wanted. Otherwise, you're not having a good time. So we've got the dog things on the left. Those are the things I'm not covering because this is a cat talk. So all the things on the right are what we are going to be covering. I'm not covering authentication. I'm going to assume that you have some way of authenticating users within your application. And when they present themselves to your application, they've got some token that proves that they are authenticated correctly. I'm also going to assume that you've got TLS encryption set up between all the components of your system. If you don't have MTLS or you don't have transport level security between the bits of your system that you're talking to, I'm not going to tell you how to set that up in this case. I'm not going to be covering token exchanges, but I will cover briefly why token exchanges may be useful. So token exchanges are where you take one token, you swap it out for another one before you do another request. I'm not going to cover the tools and techniques that allow you to do that, but we will talk about why you might want to. I'm not going to tell you how to secure databases or file shares or anything like that. That's honestly not an area that I spend a lot of time in, so I'm not the right person to tell you how to do that. And then finally, I'm not going to cover any front-end security because I am not a front-end person at all. In fact, my front ends are typically so secure because nobody can use them. They're so horrible. And that's why I won't be showing you how to do that. What we will be covering in this talk, though, is we will cover why tracking identity is important, especially in the context of a modular monolith. We'll also take a look at the basics of zero trust in messaging systems. So a modular monolith, in essence, is a message-based system, and we're going to take a look at zero trust and why parts of it would apply and which parts are important to look at and which parts you can safely ignore. We'll also take a look at personalization of data. So personalization, or in application level security, there's three phases. You've got authentication, which is I am William. This is the proof that I am William. You've got authorization, which is I'm allowed to do this. And personalization is the third aspect of that, where you get a slightly different experience based on who is accessing the system. We'll also cover token expiration and why that's something you need to be aware of within modular monoliths. And then we will cover how versioning affects the security of your application. So as you deploy V1, V2, and V3, what that means for the security in your system. And because I know there's at least one or two of you in the audience for it, you don't have to worry. There will, of course, be cat memes plenty throughout this talk. So do not worry about that if that's what you're after. I'd like to introduce you to the inspiration for this talk. This is Butterbean. He's my cat. Everybody calls him Butt, not because that is short for Butterbean, but because he is an asshole. He's the grumpiest cat I've ever met in my life. He doesn't like anybody except my daughter, which is why I can safely say you are not his favorite person because you are not her. She is not here. He only likes her, and that is it. So let's take a look at a modular monolith. What is a modular monolith? It might be useful to start with the word monolith and then see how modular fits into that. So a monolith is an application that is deployed as an entire unit. It will be one application that you run. All of the code for the system, all of the capabilities that your system exposes live within that one code base and that one application process. This makes development really easy because it's just one application that you're working on. It also makes deployment really easy. But the downsides are usually it's easy to get tight coupling between the different components within your module, within your monolith. And then you end up with what we call a big ball of mud, which is really difficult to work with. So a monolith is one application that is deployed. On the other end of the spectrum, we might have something like microservices, or you go even further and just do functions as a service. Where microservices, each capability that your application exposes would be deployed as its own separate process that you run. And you could then manage those via Kubernetes or containers or whatever you want. So the benefits of microservices are, because they communicate via messaging and they don't invoke code directly, it's much harder to introduce tight coupling between the different capabilities of your system. But the downsides are it's really difficult to work with at development time because you might have to spin up 20, 30, 40 different instances of these different components so that you can actually get your system working as a whole. A modular monolith is a hybrid between the two. It's a compromise where you develop your application as a monolith. Everything is deployed internally within one application, but the components within that application, the modules, never communicate directly with each other. They would instead communicate via messaging through an implementation of the mediator pattern. So you would have the mediator pattern, and all the modules within your monolith would send messages or publish events, and the mediator pattern would route them to where they need to go. What this enables then is that if you ever do need to take part of your system and scale it out separately, so if you take one module within our application, we can take that module out and move it to a separate runtime and have it run on its own there. Because it's no longer in process anymore, though, we need a way of communicating with it still. And in this case, most people would introduce some type of message broker. And then that module would talk to the message broker, and the implementation of the mediator pattern would decide whether or not a message needs to leave the process. And if it does, it would put that message on the message broker and then route it to the module that is being deployed separately. So a modular monolith, the intention behind it is to still maintain low coupling while getting ease of deployment and ease of development so that you can get options in the future to scale things out if you need to. And this is exactly like getting a cat. The analogy might be stretched a little thin, but it's exactly the same, because if you get a kitten, the first thing you do is you don't deploy your kitten within an application runtime, you deploy your kitten within a safe room in the house. And you typically keep the kitten there for somewhere between a week and 2 weeks until they're comfortable with the house or the room that they're in. Instead of an API gateway, you'd have a name that you would interact with the cat with. And instead of modules, you'd have different capabilities that your safe room has for the cat. You would have toys for the cat to play with. You'd have food that it can eat in the room. You'd have a litter box because food has another part to it that you need to deal with, right? And I will admit the analogy breaks down a little bit here. So instead of a mediator bus to talk between these components, you'll just play with the cat and give it affection and attention and let it know that you are now its people. Eventually, though, you can start taking some of these capabilities out of the cat's safe room and move it somewhere else. So you can take the litter box and move it to the bathroom, for instance, and now suddenly the cat has slowly got access to more of the house, and you can eventually let the cat play with the rest of the house. This is a picture of Butterbean when he was a kitten. Originally, when we got him from the rescue center, they said he was a girl, so that was weird. That's why he's got a little pink collar on, and his name was Cammy back then. So let's take a look at what happens when you let your modular monolith out. So once you take your monolith and you scale something out, what does that mean for security? This is a picture of a cat called Jan. It's a friend of mine, Renee Naykamp, who's got this cat. It is not a picture of the cat butt, but it is a picture of a cat butt, so I think it might still work. Now, when we take our modular monolith and someone interacts with our system, what they would do is they would present some sort of user token to say, I am William, here's the token that proves that I am William. And all they have to do is pass that token into the API gateway, and then most of the frameworks you use to develop this will be able to read the user token from system thread, current principal, or something like that. You can just get the context of who is using your system from the code within your application. And this works really well, but what happens if you move a module out? So this module that we've moved out, we've scaled this part out. Now our application needs to talk via a message broker, and then our mediator pattern talks to that message broker. So we're able to get the parts of the system talking to each other, but we no longer have that identity associated with the user in process. Because module C is now out of process, we don't have the user information. So what we tend to do is when we send a message from a module within our system, a good approach is to include some sort of representation of the user identity along with that. So as the message flows through the mediator pattern across the message broker and back into the inbox of the module that we've scaled out, if we include the identity as part of that message, either as a header or an explicit property on the message, it means that we've got that identity that persists even across a separate process. So an example of doing this might be if we have a charge credit card message, perhaps just adding a property on there that says this is the user ID that triggered this action. We'll revisit this a little bit later in the talk because this doesn't always work, but you need to at least think about having some sort of way of passing that identity across the application when you're working with it. So Butterbean loves person, I should say. He loves my daughter, and he loves to lie on her chest. But everything he does has to be around her. For him, the action of the person is involved in everything he does. If she's in bed or at school or something and he wants attention like this, he'll settle for someone else's chest, so the person is still involved in what he's doing. It's really annoying when you're trying to read a book, because if you're lying in bed reading a book like this, he'll put his head here and bump you and annoy you, and eventually you have to lie like this so you can read. It's a really annoying thing to do. But when you are in the modular monolith and you're going to send a message, start thinking about, well, can I package a user as part of this message so that when I send it, it's got some identity that goes along with the message. And we'll revisit ways that you can do this in a little bit as well. So even when you're working within a modular monolith, long before you think about scaling parts out, include a user identity as part of the messages that you send so that you don't rely on having that information contextually available later on. It will make your life a lot easier in the future. Let's take a look at authorization. So this is a picture of my driveway. Butterbean's one of his favorite places because the dogs can't get there, so they can't annoy him. It's sunny, it's warm. There's a tree that he can scratch and sharpen his claws on. There's lizards he can hunt and pounce if he's feeling playful. He quite likes the spot. And if I have to take the dustbins out on collection day, the driveway is probably about 30 meters or so, give or take. So I take the dustbin up with me, and he gets very affectionate. He rubs himself on my legs. He's very happy that I'm taking the rubbish out, up until I turn around and try to come back down the driveway. Then he gets angry, and he attacks me. He tries to scratch my legs. He bites. I have to try and run to outpace him on the way back down the driveway. It's like in his mind, he thinks, oh, you're leaving now forever. That dustbin that you're taking must be your most prized possessions. Goodbye, don't let the door hit you on the way out. And as soon as I turn around, he's angry that I'm coming back into his house. He's trying to say, no, you're not allowed in. What an asshole. So before we get into authorization, I just want to do a quick recap on the difference between commands and events, because it is material in this case. So a command is sent to a specific logical owner. Think charge credit card. Multiple places can request that a credit card gets charged, but it should go to one module that owns the charging of credit card information. So it can come from multiple places, but it goes to one logical place. The opposite of this is events. They are published by a specific owner, and they can go to multiple places. So once a user's credit card has successfully been charged, that module would publish an event to say, user's credit card successfully charged, or credit card denied, or something like that. So it comes from one place, and it can go to many different interested parties. So how do we authorize this in message-based systems? Well, the first thing I'm going to do is we've got a lot of stuff in this picture. I'm going to simplify it a little bit because the API gateway doesn't really matter for explanation here. I'm also going to get rid of some of the other modules, just so that we've got a slightly simpler picture that we can talk about. So we've got internal modules, module A, B, D, E, F, whatever. I'm not going to show them. And they are talking to external module, module C, via a mediator and the message broker. Now, when we send commands, once a command needs to leave our modular monolith, we lose the safety of that in-process communication, which means if we take a message, we send it via mediator, mediator says, actually, this needs to go to module C, and module C no longer lives in process, so I'm going to put this on a message broker and then send that message to module C. This works okay, this is fine. But now we start getting into the zero trust mechanism. So zero trust says, well, what if somebody already has access to your message broker? How does that change the way that your system works when you deal with it? So if we have a bad actor who's trying to send malicious messages, if they somehow have the credentials to connect to our broker, they can go and put a message on that queue, and that message will then get processed by whoever receives that message. So if module C is the one to charge credit card information, a bad actor could go and put a message that says, charge William's credit card £500. Module C receives that message and says, okay, cool, great, I'll do it. And then I'm out of £500 out of pocket. So with zero trust, what you have to do is you have to say, well, somebody's already got access to my network. They're already in my infrastructure. Maybe there's a disgruntled employee, or maybe I was coding the system and I accidentally checked in the credentials in a PR. You didn't see it during the review because I fixed it on the next commit, but the credentials are still in the history somewhere. Or because Butt's an asshole, he might actually go and threaten someone and claw them until they give him the credentials. Whatever, you assume that the credentials have been leaked. But you need to make sure that nobody can send a message that will get processed if they're not supposed to be able to send that message. So the way we do this with messaging in zero trust systems is when you send a message, you also sign that message with your private key. Did anyone go to Eli's talk earlier today about asymmetric key encryption, asymmetric encryption? There's a lot of that in the zero trust space with messaging. So you sign the message with your private key. That message then goes via a mediator onto the broker, and it gets to the destination. The destination can then use your public key to validate that the message was sent by you, which means that because the other people that have got access to your broker don't have access to your private key, they can't create the same signature, which means you can validate that the people that have sent you the message, or the modules that have sent you the message, are the modules that were supposed to send the message. You obviously don't want to do this in all of your modules because I don't know how many modules you're going to have in your system. You might not know how many modules you're going to end up with in your system, and it's going to be a lot of repeated work. So when you choose your implementation of the mediator pattern, you should choose one that allows you to do this as part of the pipeline behavior. If you're in the .NET space, Jimmy Bogart's mediator package is a great one to do this. It's got a pipeline behavior. You can just go and inject and then do whatever signatures you need to do on the message and pass it along. But what you want is you want that signing and the validation to happen at the mediator level, so that when you send the message and you put it on the message broker, it's already got a signature associated with it. If that message doesn't need to go to a message broker, so if it stays in process, you don't need to sign it, because it's a lot harder to inject a message on an in-process, in-memory bus than it is just to write something to a queue. On the converse, if a message comes from the message broker, you also need in your mediator implementation to be able to take the signature that came with that message and validate that it came from someone who's allowed to send you that message. So if you are using Jimmy Bogart's mediator package, this is an example of how you might do it. You'll just go and take the body of the message, hash it up with a signature, and then append it to the message before you send it. Once you've got this, you're in a position now to be able to say, no, I don't need to process this message. This is not the message that I think I need to respond to, and you can discard it. And I think cats are a really good example of saying no to things, because they're mean, and they say no all the time, even if they don't know why they're doing it. So once you start sending messages outside of the process, you might want to consider signing those messages with your private key so that they can be validated at the recipient to make sure that the message should be processed and honored correctly. This is one of Butterbean's favorite places to hide in the house. It's quiet, it's warm, the dogs don't go in there, people leave him alone. And my daughter, when she was younger, used to say that he was reading her books while she was at school. Obviously, he wasn't doing that because he's an illiterate idiot. But he did like this place to live because it was nice and quiet and calm. And we've taken a look at how to prevent people from sending messages that they shouldn't be able to. But what about if we sent a message to them and we want to prevent them from being able to get access to any sensitive information in the message? So we don't want them to be able to read the information. So let's take a look at how we can prevent people from reading messages. So it's a similar flow. A message comes from a module, it goes via mediator, and then it goes to the message broker, which then sends it to the correct destination. If we assume again that someone has got access to our message broker, they can connect to the message broker and change the bindings and the routing so that any message that goes to module C also goes to them. So what we need to do is when we send the message, once it gets to mediator, what we want to do is we want to then encrypt that message, but not with our private key anymore. We want to encrypt the message with module C's, with the recipient's public key. Okay, so that the message body that we send in is now encrypted with the recipient's public key, so that when it gets to the recipient, they can use their private key to decrypt the message. Which means even if it does end up at the destination for someone else, if they don't have access to that private key, they're not able to decrypt that message. So to prevent someone from sending messages, you sign the message with your private key and validate it with your public key. To prevent people from reading the message, you encrypt the message with the destination's public key, and then the destination can decrypt that message with their private key at the end. So again, if you were using mediator, the code doesn't actually matter, but essentially all you do is you encrypt the message over there, and then you replace the body of the message with the encrypted one, and then when you send it along, you can prevent someone from unintentionally reading any information in that message that they shouldn't have access to. And this is the second part of Zero Trust, where you need to just assume that somebody has access to your broker and they're able to access the messages that you're sending. And then once you've made that assumption, you can start doing threat modeling to say, well, what does this mean for my application? Is it important for me to secure those messages, or is it okay just to assume that they're fine? It depends on the type of stuff that you're dealing with. So we've taken a look at stopping people from sending messages. We've taken a look at stopping people from reading messages that they're not supposed to have access to. They can still do malicious things on to your system, though. So for instance, they can discard messages. If they can connect to your broker, they can go and just take messages off of your queue and get rid of them. And if those messages are financial transactions, you've lost that information. Cats, again, are really good at dropping things on people. I think they do it on purpose. They're just assholes that way. So it's a very good analogy, I think, for also just discarding messages, just being pure destructive forces in your systems. How can we prevent people from discarding messages? So with the assumption that they've got credentials to access your broker, and perhaps those credentials that they've got allow them to make changes to the topology in the broker, it becomes really hard to outright prevent them from discarding messages. Because if they're able to connect to your broker, by the time that message gets sent via the broker, it means that they could also have changed the way that those messages are routed. So you would never actually know that those messages aren't ending up where they need to go. So if somebody does have access, really difficult to stop them. With the reading and sending messages, it was nice because we had a deterministic way. We could encrypt messages and sign messages and make sure that there was no way that they could end up where they shouldn't be. With discarding messages, it's much harder, because you can't actually stop a message from being sent to someone if they've got access to your broker. What we can do, though, is we can rotate our security credentials very frequently. So this comes from the documentation of HashiCorp Vault's Vault, obviously. And what they actually do is they provide a way to get dynamic security credentials. So instead of storing your username and password or your connection string to connect to your broker, your code would request credentials from HashiCorp Vault. And it would say, hey, HashiCorp, I want to connect to this broker. Can you give me a username and password that I can use to connect? The Vault would validate that you are allowed to ask for those credentials. Then it would go in the background and create a new user with a password for you and send those credentials back to you. The application would then connect to the broker using those credentials. And the smart bit is that after a determined period of time, HashiCorp would go and deactivate the user, so that that user would no longer work at all. And in the documentation, they've got an example for 7 days. But a lot of the time, you can scale that window all the way back down to an hour, to a few minutes. So these credentials are only applicable for 5 minutes, or 3 minutes, or even less, which means that you can keep rotating your credentials very frequently. So if somebody does manage to get your credentials, or they do manage to get access to your network, they've only got a short window of time where they can do destructive behavior within your system. So if you can keep rotating those security keys or connection strings frequently, you reduce the chance of someone being able to have a negative impact on your system in this case. A lot of the other key vaults like Azure not Azure KMS, AWS KMS and Azure Key Vault don't do the dynamic security credentials, but you can quite easily just script those with PowerShell scripts or commands and do something similar yourself. It's not too difficult to implement. What about personalization? So that is about as much as we're going to cover with the basics of Zero Trust. If you want to talk about Zero Trust and more, come grab me afterwards. But personalization, like I said, is where you've got authentication, authorization, and personalization. So authentication, I am William. Here's the proof that I am William. Authorization, I'm allowed to do this or I'm not allowed to do this. And personalization is maybe we've got a dashboard that shows all of the transactions that have been processed for the day. Everybody can see all of those transactions, except William can't see the dollar amount of those transactions because he gets really jealous or something. I don't know. But we change the behavior based off of who the message is going to. Now, the example message we've been using before this was the charge credit card command. This one doesn't really work well for this scenario because everything in this is pretty sensitive. So you don't really want anyone that shouldn't have access to this message to see it. But maybe something like order shipped is a more applicable message. So order shipped, once we've processed everything and we've given it to the courier and it's gone off, we might just want to say, hey, everyone, this order has been shipped. And this is a fairly benign message. But if you're working in a space where you've got GDPR compliance you have to be aware of, or in South Africa, we've got POPI, protection of personal information. The stuff that's personally identifiable can only go to destinations that have got a legitimate interest in using that information. So you can't just send the address, contact number, and email address to everybody who's interested in the event. There's a couple of options here. The first is we can have different types of messages with different structures. So we can say we want to send order shipped event that doesn't have this information, and then we'll send an order shipped event that does have this information somewhere else. But then you start kind of having to have different classes for different security roles, and it becomes a bit of a pain to introduce. Also, it means that the sender, the person who's publishing the event, or the module that's publishing the event, needs to know which parts of this need to go to which different locations. So maybe that's not the best approach. Something else we could do is we could, instead of having strings for those, we could have encrypted strings, where we could say, well, I want to do partial encryption on this message so that only people that have got access to the private key that I'm using to encrypt the message can see these properties. In .NET, we can take this a little bit further and we can have attributes, and we'll see why attributes might be attractive in a bit. But essentially what we do here is we say, well, we're going to publish this event. These properties on the message are sensitive. So only part of this message needs to be encrypted, and the rest of it doesn't have to be encrypted. And you can encrypt it with the public key of who the destination for that message is. So, and if you're using a mediator again, it's fairly simple here. You just go through all of the properties that you need to encrypt and replace them with encrypted versions of those properties. The nice thing with attributes is that you can do things like specific roles. So if you're a part of the dispatch role, you should be able to have access to things like the address, the contact number, and the email address, so that you can get hold of whoever you send in the parcel to. Customer service might only be able to access the email address so that they can reach out and make sure that you're happy with your purchase or something like that. And by using different roles like this, it means that you can configure what sensitive information needs to be readable by who. And this is really nice because you can do, this is useful within the bounds of a modular monolith already. You don't have to be scaled out to start using this sort of information. So if you make sure that sensitive data is only readable by those who are allowed to read it, it means that you've got fewer messages that you're sending, so less message contracts that you have to maintain. And it also means that you can make sure that only people that know how to use that information or have legitimate interest in that information are able to use it. Let's have a look at token expiration. So if you're using JWT tokens or JOT tokens, those tokens have to have an expiration period associated with them as well. And if a user presents you with a JOT token, you need to validate that that JOT token is still valid. Now, Butt likes getting his belly scratched sometimes, but only on his terms. So he will present his belly, and you're allowed to scratch it for a little bit, but if you take too long to get to him to scratch it, or if you scratch him for a little too long, you're no longer allowed, and he will latch onto your arm with his front paws and use his back paws to try and rake your arm to get the insides of your body to be on the outsides of your body. Which is really unfortunate, because the inside of my body is where I keep all my blood. So there's a time period where you are able to scratch his belly, where he'll tolerate it and allow it, but if you miss that time period, it's expired. And the same thing happens with JOT tokens. So if we're talking about a JOT token, we've got a message and we send, let's say we're going to send the entire JOT token along with a message. So we're not just using user identity, but we're sending the entire token along with it. That message ends up in the destination module and it gets processed and everything's fine. But because we've taken that module and we've moved it out of process, all assumptions that we make about when that message will get processed no longer hold. There could be other messages sitting in the queue. There could be lots of messages sitting in the queue. Maybe module C was calling a third-party service, and that third-party service was down for whatever reason. It's now come back up, but there's a whole queue of messages that module C needs to process before it gets to your message. So if we send a message and it ends up at the back of the queue, by the time it gets to the front, that JOT token that we're using to represent the user identity, that could have expired. And we need a way to deal with that. So there's three ways that we're going to cover and how to deal with expired JOT tokens in this session. The first is just to forward the user identity along with the messages that we send. The second is looking at custom data structures and seeing how we can use that. And then we'll take a look at token exchanges and why that might be applicable. So when forwarding identity, what you do is, once the user logs into your application and they present their JOT token to say, I am William, instead of taking that entire JOT token and attaching it to the message, you just include the user identity as part of that. So the example we had earlier, charge credit card, we stick the user ID at the bottom of the message and that just goes along. So there's no expiration with this because it's just the user identity. The problem with this is that if you've got someone who's got access to your broker, they can go and put a message on the queue and put a different user ID there. They can say that William authorized this to take place. So it might not be sufficient to just forward the user identity. What about using the custom data structure? So this is where, before you send the message, instead of just appending the user ID to the message, you add some additional information to the message as well. You might create a user identity object which includes the claims that the person has got. And then you would have a hash of this user identity object so that nobody could tamper with it. So that when you receive the message, you can then go and say, well, the user, at the point in time that this message was sent, had these claims, so therefore they're allowed to do this. Again, there's no expiration here, so you work around the token expiration that way. But very similar to just sending the user identity, if somebody can get access to the message that you're sending, they can copy that user identity object and put it on a different message. So they might be able to tamper with future messages. They can also do replay attacks, where they take a message off of the queue and then put it back on the queue 5, 6, 7, 8 times. So that message could process 5, 6, 7, 8 times because the content of the message is still valid, but they've tampered with your system. So the third option that we're going to look at is token exchange, and that's where you separate the internal part of your system from the external part of your system. And logically, in your mind, you have two separate things. So the user comes to your system and they present their JOT token, and this is represented as them presenting external identity to you. You then say, okay, that's fine. You are who you say you are. Your JOT token is still valid. It hasn't expired yet. So what I'm going to do is, instead of attaching your JOT token to the message, I'm going to replace that with my own JOT token. So the module itself would have its own token that represents who it is. The core part of this is that those tokens need to have a longer expiry, and you're making an assumption that this is now internal to your system, so you're thinking that there's going to be a higher level of trust here, so it might be okay to have a longer expiry in this case. It must also include a hash of the message, a full hash of the message, which includes the message ID. So every time you send a message on most brokers, you get a unique message ID for that message. You can use it for deduplication or implementation of the outbox pattern. And if that message ID forms part of the hash of the message, it means that nobody can do the replay attacks, because they can't take the message and copy it again, because it will have a new message ID, and that hash will be different. So you can validate that people aren't putting duplicate messages on your queue that way. You could also use refresh tokens for this. So refresh tokens, when you get a JOT token, depending on the provider, you can request a refresh token, which basically says, I've got this token, it's going to expire soon, give me another one, and it'll give you a new token to represent that. So you could do the same thing with refresh tokens as well. Ultimately, though, no matter which technique you decide to go with, you do need to be aware that when you start scaling parts of your modular monolith out, you are going to have to deal with expired tokens. It's going to be a reality. So you need to start thinking up front with how do you deal with that? Are you okay with just sending the user identity, or do you need a bit more security along the way as well? So that if you do have a system that's really slow, this is an actual picture of the performance of my code. If you do have a system that's really slow, and by the time the message gets to the front of the queue, you know that you're going to be able to process that message as well. Let's have a look at versioning systems. So when things change. So I got Butterbean when my wife and I got married many years ago. I could still grow hair then. Life has changed a lot. We've had children, we've had mice, we've had birds, we've had dogs. And he made sure that we knew how miserable he was every time something changed. So let's have a look at how we can deal with changes within our systems. Now, version changes are when you make a change to your software and you deploy a new version. It's not always going to be a problem with modular monoliths that have been scaled out, but sometimes it is, especially if the version changes that you're doing change the message types that are sent to the broker. So if we send a message from module A to module C and everything just goes fine, that's great up until we change module A, or we change the rest of our modular monolith and we make some sort of change to the message contract. Maybe we are sending the charge credit card message, but instead of just sending the whole thing like this, we decide, well, the credit card number is sensitive. So some people should be able to read it, but other people shouldn't be able to read it. By changing the contract of the message, we need to be able to decode that message in module C. So if we send a new version of the message, module C needs to also be able to read that new version of the message. But it's not quite as simple as just deploying a new version of module C, right? Because there could be other messages in the queue for module C that were sent using the old format. So you've got two different formats of the messages on the same queue that are going to get processed by the same endpoint, and it needs to be able to deal with different message contracts. So when that message flows, if module C is able to decrypt both of those different properties or is able to deal with different message formats, then you'll be able to process those messages successfully. Otherwise, it's going to fail. And this, a way that we could implement this is very similar to how we've done everything before. So we sign the message using, when it gets to our mediator pattern, then we send the message along and the message broker says, cool, here's the signed message. I don't know who signed it or what key it was signed with, but good luck. And we could sort of try and decrypt it with all the keys that we've got access to. That's going to work, I suppose, badly, and maybe your code will start performing like mine then. But another approach that we can do is when we send the message, we also include the key ID of that message. So that's the identifier of the key that was used to sign that message, which means that we can then use any number of different keys to sign messages as long as we have some sort of secret management tool that we can use. So AWS KMS or Azure Key Vault or HashiCorp Vault. What you do is you receive a message and it's key ID 1. So you go to your secret provider and you say, I would like to get access to key ID 1. Please give me the key so that I can decrypt the message. And the vault that was then responsible for saying, yes, you are allowed to have access to this specific key, or you are not allowed to have access to the key. And when you've got something like this in place, you can do really quick key rotations for your security. And if you've got really quick rotating keys, it's a lot harder for someone to be able to get access to that and do something in your system. If you've got constantly changing keys, it's much harder for someone to be an asshole to your system. So your middleware that you're using should be able to decrypt using different keys, and you should practice using different keys for different types of messages. Leverage some of these secret management tools that are able to do this for you. So a quick recap, and then we can escape. I know it's been a long day for everyone, so I thought let me try and make this a little bit of a shorter session so we can be a bit more energized. Think about passing identity with your messages at the beginning, even when your system is still a modular monolith, because once you've got identity as part of the message flow, it's a lot easier to keep that identity when you start splitting things out later. Leverage your middleware to be able to sign messages and decrypt messages so that you can make sure that only people that are supposed to send those types of messages are able to, and then validate those signatures, and then do the same with encryption so that people don't get access to your data. Obviously, you don't need to do all of these, but if you are in an environment where zero trust applies, then you can start looking at these techniques for signing messages and decrypting messages. Personalization is a great one, and this makes a lot of sense even when you are still within the confines of a modular monolith, because when you're publishing messages within that monolith, you can decide who gets access to those secrets and who is able to read those sensitive properties on the message. Be aware that token expiration is a thing, and you are going to have to deal with it. So make sure that you know how you will deal with it in the future. And use something like a vault to manage your secrets for you so that you can do frequent key rotations and you can use multiple different types of keys to be able to send these messages securely. If you do that, you might have a good time having a fun little system that you can work with. If you don't, that's also fine, I suppose. None of these are hard and fast rules that everybody must do. Originally, when I was coming up with this talk, Butterbean wasn't going to feature at all. It was just going to be cat memes because they're objectively hilarious. On the ranking order of humor, sarcasm might be at the bottom, but cat memes are right at the top as perfect forms of humor. Unfortunately, though, Butterbean passed away while I was preparing the talk, and I thought, what better way to honor his memory than to get up in front of a room full of people that didn't know him and tell them all what an asshole he was for an entire 45 minutes of their lives. And I hope that maybe as you go back to your day jobs and you start thinking about, well, do I need to do anything about the security of my system? Maybe you'll think what an asshole this cat was and how miserable he made my life, and you'll smile. What a grumpy asshole of a cat that I miss terribly. Thank you. I do have plenty of time for questions. Otherwise, if you want to catch me downstairs, I'll be at the particular booth. I didn't even say that. I work for particular software. We make N-Service Bus, which is if you want to distribute your systems and scale things out. Obviously, I didn't talk about any of that there. So if you do want to talk to me about any of either zero trust, I'm quite interested in zero trust in messaging systems, or if you just want to talk about cats, come grab me at the particular booth. I'll be there after this and tomorrow. Thank you.